This is the answers to test number 2. You were given 3 factoring problems. One was a trinomial, which most people got correct, and I'll show you the mistake that people did make, however. But this is what the factors are. The factors of 28 would be 7 and 4. And you want to make sure that whatever is there and whatever is there add up to -1 in the middle. So it comes out to 4 and 7. 4 times 7 is 28, and this is 7x, this is 8x, and to get -1x, the 8 has to be negative, the 7 has to be positive. So therefore, there's the 7, there's the 8, and that was the answer to the question for 5 points. The thing that most people got wrong, when they got it wrong, what they did wrong was to put the positive sign here and the negative sign there. Otherwise, this was a problem that most people got correct. Problem B. Problem B was a problem that you would do by grouping. So you would group these two and these two. And the greatest common factor here would be 3x squared, and you would be left with 3x plus 1. That takes care of this part of the problem. It's like 2 problems in one. This you would do by greatest common factoring. This you would do by greatest common factoring. And you get the same factor as here, which is no coincidence. It just, that's the way the problem was set up. Now you would take out that as the common factor. I was very, very surprised with this problem, which you would write as x to the third minus 3 to the third, because so many people got this right. And they had the formula pretty much nailed. I mean, they knew that you take out the x minus 3 and you wind up with x squared plus 3x plus 9. In other words, you would take out the x minus 3, and then what's left over, you would have to just make sure that this was, if this is negative, therefore that's positive, therefore that's, and that's always, that's going to be always positive. And that's the answer to that. And that was 15 points. And, as I said, a lot of people got that right, no problem. Problem number 2. 2i divided by 3 minus 5i. So what this is a fraction with an imaginary denominator, and the idea is to multiply by the complex conjugate, which is 3 plus 5i. And the reason we want to multiply by that is when we multiply this by this, the middle term drops out, which is exactly what we want. This becomes 2i times 3 plus 5i. We'll get to that in a minute, but now let's go down here. So it's really 3 times 3 is 9, and the middle terms drop out, so you don't even have to worry about the negative 15i and the positive 15i. And then the next thing would be negative 5i times positive 5i is negative 25i squared. Continuing. Now you could just work with both the numerator and the denominator. In the numerator, you would get 6i plus, and now 2i times 5i would be 10i squared. Now, a lot of people simply left it like this without going over here. And I've said that, you want to leave stuff as in the factored form if possible. But in this particular problem, it was beneficial because you get 6i plus 10 and I squared is -1. So this would come out to, and let me go down here because I'm going to need this for the denominator. But down here, you would wind up with 6i minus 10, and that would be it. That's the numerator. Now over here, you would get 9 minus 25 times -1. Because I squared is equal to -1, and 9 plus 25, which would be 34. That's the denominator. It's amazing how I say 34 and I write a 32. That's pretty incredible. So that's what this answer would be. Now, I accepted this for full credit. However, many students realize that in the numerator, you could factor out a 2. And if you do that, you could then cancel out the 2 with the 34 and reduce it even further. And wind up with, and then switching it around in terms of a plus bi, it would be -5 plus 3i divided by 17. This is the real answer. However, if people had this, I did give them full credit. But, you know, in reality, this is the correct answer. And a lot of people went even further and did this. And this was not necessary. But of course, it's a correct answer as well. Then we have the quadratic formula question, which is problem number 3, where you have 3x squared minus 2x equals 1. Okay, and the first thing you need to do is to bring this 1 over. And you get 3x squared minus 2x minus 1 equals 0. Now, of course, this can be factored. It could be factored, but that's not what the question is asking. The question is not asking for you to solve the problem, you know, factor and then find the values of x. The problem doesn't say solve by, you know, factoring or solve any way you want. It specifically says use the quadratic formula. So step one is to identify A, B, and C. And then write the quadratic formula, -b plus or minus the square root of b squared minus 4ac over 2a. And the next, so that was the second step. The third step is the substitution. So very carefully, a -2, right? So that's what's in the formula. That negative was in the formula, but there's also a negative in front of the 2, so there were two negatives. Plus or minus the square root of -2 minus 4 times 3 times -1. This is where a lot of students made mistakes in the evaluation of this whole conglomeration of signed numbers. And of course, step 4 is the working out of the problem. And you get 2 plus or minus the square root of 4, excuse me. Oh, I left out the square, -2 squared. Just, you know, just checking it to make sure that I didn't leave anything else out. That's essential, as I keep telling you.
Okay, so I made that mistake. That's a positive 4 there, but I caught it. It's okay to, as I've said, it's okay to make a mistake. You need to catch the mistake.
This comes out to positive 12.
Some people left the answer like this. So this was a common error that some people just did this and that was it. Now, this was an 8-point question. So, I did give partial credit for anything that resembled a correct answer here. But really, you should go beyond that to 2 plus or minus, and some people left the answer like this. Some people had this is what a lot of people had, and I was kind of dismayed by this. They had the quadratic formula incorrect so that everything in the numerator wasn't being divided by 2a. Only what was in the radical was being divided. This is wrong. So this was a wrong answer. And, that was obviously a big source of mistake, and you lost some points for that. But, and a lot of people left the answer like this. A lot of people left the answer like this. And said, this is the answer to the question. That's not the answer to the question. You have to go further. Excuse me. You have to go further. You have to, evaluate this. X is equal to 2 plus 4 divided by 6, and X is equal to 2 minus 4 divided by 6. This is 1 because it's going to be 6 divided by 6. That comes out to 1. And this would be X equals negative 2 over 6. Reduced to lowest terms, this comes out to negative 1/3. So X is equal to negative 1/3. These are the two answers. This is all I required for that problem. Problem number 4. Back up here. Problem number 4 was, I think I could squeeze it in here. So let me try it, see if I could do that. So you were given f of x is equal to negative 2x squared minus 8x minus 1. And you were asked to find the axis of symmetry, the vertex, the x and y intercepts, and sketch the graph. Some people in the class did this in a way that I did not cover in class. There's another way of doing this, and that's the way they did it. Now, I'm not going to go into even what it is, because the way to do this problem is the way I taught it in class. And I guess either some people had tutoring from somebody who showed them the other method of doing it, who may have had the course before and did it the way they learned it in the other course, or just decided to Google how to find the various aspects, the axis of symmetry and everything on the internet, and looked at somebody else's video. What we do is we complete the square. Now, the thing is, students used other methods of doing the problem, but those students were not following directions. The directions said express in standard form using completing the square. So therefore, all those methods that people were using to solve this, that they learned somewhere else, the other method, was incorrect, because I specifically request a method using completing the square. But I didn't penalize students for doing it other ways. Although, as I just said, they did not do the problem correctly. So you have to learn. And, as time goes on, I'm going to be more and more strict about what I accept and what I don't accept. And, you know, especially right up to the final exam, which needs to be kind of perfect. Okay, so completing the square would involve factoring out a -2, having x squared plus 4x, putting the -1 out over there. Then completing the square means taking half of 4, which is 2. And squaring the 2 times 2 would be 4, and that would go over there. And that would become -2 times 4 is -8. So you have a -8, you need to offset the fact that you're putting a -8 over there by doing the opposite. So some students actually added on to here, instead of a +8, a -8, and wound up with this number here being -9. And they had the wrong vertex. So so let me just finish the problem off. This was +7. Y equals -2 x plus 2 squared plus 7. This is standard form. So I specifically requested general form to standard form by completing the square. And this is standard form using completing the square. The other method was incorrect, and I gave as many points as I possibly could. Now, the vertex is -2, 7. And the mistake people made is they had -2, -9, because they put the -8 instead of the +8. Some students had what was some of the other answers? Well, a -7. You know, there were a lot of things done to this very, very simple addition of 2 signed numbers that were like just messed up completely. Not too many, though. A lot of people got to this point. The axis of symmetry is x equals -2. And then, you know, as I've showed the class, this is what, you know, I would do next. -2, 7. I was doing throughout the time I was teaching this, showing that that's the vertex over there. And this is the axis of symmetry, and indicating it on the actual sketch of the graph that that's equals x equals -2. But now you need to know the y-intercept. The y-intercept, the shortcut, is to let x equal, so go back to over here, the shortcut would be, over here, right over here, here. Okay, so the shortcut way of finding the y-intercept is to just go back to this equation. Let x equal 0, let x equal 0, and the y-intercept is always that number. So that's -1. And the y-intercept is the point 0, -1. So 0, -1. And the graph would probably come down like this and like this. Okay, that's how the axis of symmetry helps us to draw the graph without knowing the x-intercepts. We don't know the x-intercepts yet. So I wanted to know that. I wanted to know where this graph crossed the x-axis over here and over there. So the next step is the difficult step to this problem, which is to take this equation, y equals -2 times x plus 2 squared plus 7. Let y equal 0. Bring over the +7 by adding -7 to both sides, and then turning the whole equation around so that it becomes -2
times x plus 7 squared equals -7. Then divide by -2. And this will give us x plus 2 squared equals 3.5. Some students got this wrong and made this -3.5 because they left out the negatives because they didn't have this correct. So, once mistakes were made in terms of this situation up here, then everything else became an incorrect. So that's why a lot of students lost points. So think about that with your own situation. And we take then the square root of both sides of the equation. X equals the square root of 3.5 was 1.9 to the nearest tenth. So plus or minus 1.9. Bring over a -2. X equals -2 plus or minus 1.9, which meant that the answer was x equals -2 plus 1.9, which came out -0.2. And x equals -2 minus 1.9, which came out -3.9. And then you were supposed to go back to the sketch and say, whoa, which this makes perfect sense, because look how close it is to the y-axis. It's like hardly moving. And the reason is that the x-intercept is the point -0.2 and y is equal to 0. It's right on the x-axis. This was out here, so that was -3.9 comma 0. And that was the complete answer. That's what I required for this entire problem. It was a 12-point question. And, a lot of people made a lot of mistakes along the way because of all the various things that could go wrong with a problem like this. And that's the answer. Problem number 5. F of x equals x to the third plus 6x squared plus 5x minus 12. This is a 10-point question, and I never saw a problem done in so many different ways as students did this problem. Now, a lot of people, well, let me do the problem, and then I'll tell you how I gave partial credit, because there was a lot of partial credit in this problem. This is the equation that you're solving. And if you listed all the possible rational, see, it's got to have one rational 0, because that's to an odd power. So you would have to, and I didn't say list all the rational zeros, but the final exam will. If this is on the final, which I've seen it many, many times, they will say as a first step, list all possible rational zeros. Basically, it's going to be -12, +12, -6, +6, -4, +4. So we're listing all possible rational zeros, which is determined by all the possible factors of 12 divided by all the possible factors of 1. And these are all the possible factors. Now, since it's 1, we don't have to even bother putting denominators, because the denominator is just going to be 1. -3, 3, 2, -2, 2, -1, 1. And people did it every which way. I never saw a problem. Even more people did this problem in their own way, quote unquote, than the previous problem, and everything was tried. the way I did the problem when I was doing the problem was to simply take synthetic division. See, this was a problem which was really testing your knowledge of synthetic division, because that's not the only way of finding out what a rational zero is. There are other ways of doing it, which people used, obviously not following my advice. Okay, they were doing it their own way. That's okay. But I just chose a value. The value I chose at random was simply -3. In other words, with all these values given, I just kind of picked one of the ones in the middle, which was -3. Some people put down I mean, people did synthetic division incorrectly. That was one of the mistakes. Now, -3 times 1 is -3. 6 and -3 is 3. 3 times -3 is -9. -4, +12. That's what we're looking for, because that cancels out, which makes this 0. This is one of the zeros. This becomes x squared plus 3x minus 4. And this could be factored. Which would give us x equals 1, x equals -4. And what I wanted you to do at this point was to list find all the zeros. So, if you were doing this problem, you might have said, okay, here are the zeros. The zeros are -3, 1, and -4. That's one part of it. And the linear factorization would simply be the factors that, that came from these zeros, which would be x plus 3. In other words, the opposite of -3, +1, -4. X minus 1, x plus 4 equals 0. And that's the end. That's it. That's the whole problem. And that was worth 10 points. See, a lot less work than the previous problem, obviously, a lot less complicated. So people did this problem so many different ways. It's really quite amazing. A lot of people got to this equation and used the quadratic formula. I mean, you could use the quadratic formula. That wasn't a problem. If people used the quadratic formula and got x equals 1, x equals -4, or if they had used -4 up here to begin with, or 1 up here to begin with, that would have been okay. So whatever they got as an equation over here, they used the quadratic formula, and they got the other two zeros, which is fine. I have no problem with that. This is the question 5, problem number 6. See, now we leave chapter 2, we move to chapter 3. And here was the first problem. 3, x to the 5th, y to the -3 raised to the -3 times 5x to the -2 raised to the 2nd. And the way I showed the class, so if you watched the video of the way I did this problem in the actual lesson where this was taught, or if you saw the review for the test, and I must say that for the review for the test, number 2, there were 98 views, which is the most number of views I've ever had on any video that I've uploaded to YouTube. So that was good. I was so pleased to see that almost 100 views for this particular review, which meant that a lot of people kept going back to it, which is really, really exactly what the purpose of doing a review in class, recording it, uploading it to YouTube. That's exactly
how you're supposed to study. By keep going back to the sample problems. That's the way to do it. Okay, anyway, this is the way I do this problem. Again, there are lots of ways of doing it. This is the way I do it. So of course, this is the way I'm going to show you. So everything gets raised to the negative third power. See? Everything gets raised to that, and everything gets raised to the second power in this category. So there's kind of two areas going on here. And now I would draw a line and create a fraction. Draw a fraction line, 3 to the negative 3. Now, if it has a negative exponent, it immediately goes down to the denominator. Don't even work it out. Just immediately use the negative to bring it down into the denominator. And this would give you x to the 5th to the 3rd. This would give you y to the negative 3 to the 3rd. This would give you 5 to the 2nd because it's a positive exponent. And this would give you x to the negative 2 to the 2nd. This is, how I would do this problem. And now you do each one. So 5 squared is 25 times x to the negative 4 divided by 3 to the 3rd is 27 times x to the 15 times y to the negative 9. This obviously you can't do anything with. This comes next. X to the negative 4, and you could take this aside, x to the negative 4, and then it's division. Or you could say, well, let me follow through. X to the negative 4 minus 15, which would be x to the negative 19. So from here, you could have gone to 25 times x to the negative 19 divided by 27 y to the negative 9. And at this point, you would again use the negative characteristic and make this 25 y to the 9, because the negative means that it goes back up to where it started from. If it's a negative exponent in the denominator, that means that everything then goes back to the numerator, which is what I did there. And this being in the numerator would bring it into the denominator. And that was the answer. And as I've said, I'm not going to go through all the different ways of doing it, but you could have done this problem a lot of different ways. This is the way I see it. This doesn't mean it's the only way. If there are 5 ways of doing this problem, I'm just showing you one way of doing it, which is the way I like to do it. Nothing wrong with that, as long as it's the right answer. Problem number 7. Simplify. Negative 27. A to the 15th to the negative 1/3. Again, the first thing that I would do would be to use the negative exponent to go 1 over negative 27 to the 1/3 times a to the 15th to the 1/3. See, I'm using the negative there to put everything in the denominator. And from here, you would take the 3rd root of negative 27. In other words, 1 over the 3rd root of negative 27. And here, I mean, obviously 1/3 of 15 is going to be equal to
a to the fifth.
And the third root of negative 20, in other words, what number times itself 3 times will give you negative 27, and the answer is negative 3. Many people had that. I suggested putting the 1 in the middle. I wasn't going too crazy over that. If you didn't do that, you know, fine, but this was the answer to the question. That's it. And there were a lot of things that went wrong with this problem. I can't even, I think a lot of people, I don't, you know, I'd have to see a particular one, but I remember that a lot of people did 27 minus 25 and got 2 or something. I mean, a lot of things went wrong here. Okay, problem number 8. Can't go through all of them. It's impossible to do that. Problem number 8. The square root of 27, a to the 7th, b to the 8th, c to the 5th. The idea here, 5-point question, is to separate this into a perfect square and whatever is left over. So this is 9, this is 3. This is a to the 6th, this is a. B to the 8th is already a perfect square. C to the 4th and C. Because 6 plus 1 is equal to 7. 4 plus 1 is equal to 5. And this becomes 3, a to the 3rd, b to the 4th, c to the 2nd, times the square root of 3ac. Very few people got this wrong. This was pretty good in terms of people getting it right. Then this is 5 times the square root of 32x to the 4th. Okay, let me, okay. So the way to do this problem is to, again, separate the perfects, just like we did here, except you're doing it twice, and it's a lot easier. But you want to separate what you're given into a perfect square root of a perfect square and whatever is left over. So here we get 7x squared times the square root of 9 times the square root of 2 plus, and let's do one at a time. So 7x squared times 3 times the square root of 2, which would give us 21x squared times the square root of 2. That's the simplification of this expression right here. Becomes that. And now over here, you get 5 times the square root of 16, well, x squared, x to the 4th. That's the perfect square, and in here is a 2. So this becomes 5 times the square root of 16x to the 4th, which is 4x squared, times the square root of 2, which becomes 20x squared times the square root of 2. A lot of mistakes here. The mistakes were here for the most part. And the answer, of course, because this is what determines if they're like terms, right over here. So, you know, it's going to wind up x squared times the square root of 2, and the 21 and the 40 is 41. Some people did this. They put the x squared underneath the radical. That x, and a lot of people then took the square root of x squared and got x. A lot of people, you know, did it like this. That x squared does not belong underneath the square root sign. It belongs outside from over here. See, we took the square root of 16x to the 4th and got 4x squared. So that should have been outside. In general, if a student had I forgot which problem that was. I think it was later on. Okay, we'll do that later on. But that's the answer to question number 9. Just like that.
The product of the square root of 2x plus 7 times 2x minus 3. Almost nobody got this wrong. Few people did, 20, how many students took the test? 23 people took the test. So, people are going to get it wrong, obviously, but not too many. This becomes 2x. This gets to be -3 times the square root of 2x. This becomes +7 times the square root of 2x. This is -21. So the answer to this question was 2x plus 4 times the square root of 2x minus 21. That was it. That was the whole thing. Yeah. Okay. Problem number 11, let's do over here. 20x divided by the square root of 5. So we want to rationalize the denominator by doing this, multiplying numerator and denominator by the square root of 5. You get 20x times the square root of 5 over 5. Some people, well, let me give you the answer. So, and then really, when you get to this, it jumps out at you that you have to simplify this. This is not as complicated as that other problem was earlier where you had a simple problem. Problem number 2 is very similar to this problem, except that this is a radical. The other one was an imaginary number. But that was much more complicated and not as obvious that you had to simplify. But this just jumps out at you. And the answer is 4x times the square root of 5. This was the answer. A lot of people had this. And it wasn't clear to me if they were putting the x under the radical. So I took points off for that because I wasn't sure if they were giving me this answer or they were giving me this answer. If this is the wrong answer, this x is outside the radical. So that's what you have to keep it as, outside the radical. Here it's under the radical. So that was a possible area of a mistake. Number 12. Number 12 was a radical equation, and this is what you were given. And you square both sides of the equation. X plus 5 is equal to x squared minus 2x plus 1, brought over an x, brought over an x, brought over a 5, x squared minus 3x minus 4 equals 0. As I told you, this will always be able to be factored. And those are the factors. And x is equal to -1, x is equal to 4. These are the two answers. And it was incumbent upon you at this point to check for extraneous solutions. So it was, and when you check for extraneous solutions, you don't go back here, you go back to the original equation. So it's the square root of x plus 5 equals x minus 1. And when you put the -1 in, you get the square root of -1 plus 5, which is the square root of 4, which is 2. Here, you get -1, -1 is -2. So this doesn't work, you see. And therefore, you should have written, which
Very, very few people did. Some people just, I don't know, they just said, the answer is x equals 4. It was incumbent upon you to say, and I think I took off 1 point for this, if you didn't say it, that x equals -1 is an extraneous solution. So this is sort of required. Like, why is x equals 4 the only value of this equation? Because x equals -1 is an extraneous solution. And here's the proof right here. This is required, if you're going to higher mathematics, that's required that you do that. It's, you have to indicate what's going on and why it's going on. And then, of course, if you then take the other value, which is x equals 4, this is what you get, the square root of 4 plus 5, the square root of 4 plus 5, which is the square root of 9, which is 3, and 4 minus 1, that's working out perfectly. And that's the solution, x equals 4. But many people simply, just didn't do any of this, went from here to here. Or simply gave me this without even checking for extraneous solutions. Okay, but this is the complete answer. This is the complete answer to the question that you're required to do. And again, if you're not taking any more math, in your college careers, this is, all right. But if you move on to higher mathematics beyond this, they're going to require, this indicated. That's very important. And finally, number 13. And it shocked me. Honestly, I was shocked by how many people did not do this problem the way I had suggested. Doesn't take much to shock me, but because I've been teaching for so long, I've seen everything. But in this particular problem, this is the way I showed you how to do the problem. Create a chart. Create a chart. Put the factors on top. This is the roots or the zeros. This is the multiplicity. Then I said, odd or even. Then I said, bounces or whatever happens. Bounces when it hits the x-axis. It either bounces or goes through. Okay, so the roots are 0, -3, and 1. That's obviously a very, very important thing. The multiplicity is 1, because that's just simply the exponent, 3 and 4. Odd or even? Well, 1 is an odd number. 3 is an odd number. 4 is an even number. If it's odd, it goes through. Through, abbreviating. Odd goes through. Even bounces. Right. Now, the degree, I asked for the degree of f of x. The degree of f of x, the degree is equal to the sum of the multiplicities. In other words, 1 plus 3 plus 4 equals 8. 8 is an even number, and therefore the end behavior, many, it was really shocking how many people just completely disregarded the concept of the end behavior. When I say the end behavior, this is what I want. I wanted this. That's what I wanted. That's the end, you're showing what, the end behavior. Now you want to sketch the graph. Well, you have a root at the root of 0. You have a root of -3. You have a root of 1. And since, this is where the graph is going to be taking place. That's what the end behavior tells us. If you knew the end behavior, you knew exactly where this thing is going to begin or end. We don't, I don't know how you would put that, but I like to start at the left. It comes down here like this. Some people, if you look at certain videos online, they say that, it's going to be kind of straight, like more straight rather than coming in on an angle. I didn't care. I just wanted a general view of what the thing looked like. I told you that, and so this is what it looks like. -3, it was odd, so it went through. Then at 0, it has to come back. So it turns around over here, and at 0, it also goes through. And then at 1, it has to come back. And when it gets to 1, it's even, the multiplicity, so it bounces. And this is what it looks like. This is what the graph looked like. That was it. I didn't care how far down this went, where it went. I didn't care about how far up this went, how far up it went. That was good enough as far as I was concerned. This is good enough for me, for my purposes. And, this problem may be on the final. So therefore, it's a problem that you need to do. And that was the entire exam.